Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of basic mechanical engineering. We'll dive into key concepts like efficiency and performance analysis, artificial and natural draft. Slide 1. Boiler efficiency and performance. Let's start with the concept of boiler efficiency. It simply tells us how much of the heat energy from the fuel is actually used to generate steam. For example, if we burn coal or oil, some of the heat goes into the water, and some is lost into the environment. Boiler efficiency is the ratio of useful heat output to the heat input from fuel. A high-efficiency boiler means more steam from less fuel, which is ideal in terms of saving energy and cost. There are two main types of efficiency. Gross efficiency considers the energy in the steam output without considering some losses. Net efficiency includes actual working conditions by accounting for heat losses, like radiation or blowdown, which makes it more realistic. Performance analysis of a boiler involves checking how much fuel is consumed and how much steam is produced. It also checks whether heat transfer from the flame to the water is efficient. Another term we use is the load factor. It is the ratio of actual steam produced to the maximum capacity the boiler can produce. If the load factor is low, the boiler is underutilized, and it won't run at optimal efficiency. Example: if a boiler uses 1000 units of energy from fuel and produces 800 units worth of steam energy, its efficiency is 800 divided by 1000 equals 80%. Slide 2. Heat loss analysis in boilers. Understanding where boilers lose heat is important for improving performance. 1. Flue gas loss. Hot gases leave the boiler through the chimney, carrying away some heat. These gases are necessary but also a major cause of heat loss. 2. Radiation and convection loss. Heat escapes from the boiler surface into the surroundings. If the boiler is not insulated properly, this loss is significant. 3. Blowdown loss. To maintain water purity, some water is regularly discharged. This hot water takes heat with it, causing energy loss. 4. Unburnt fuel loss. If combustion is incomplete, some fuel is left unburned in the ash, wasting both fuel and money. 5. Moisture loss. If the fuel has water content or moisture, energy is used to evaporate it. This heat does not help in steam generation. The goal is to minimize these losses using better design, insulation, and combustion control. Example: installing a heat recovery unit in the flue gas path can reduce flue gas losses. Slide 3. Natural draft. Now let's understand draft, which is the flow of air and flue gases through the boiler system. Natural draft is the most basic form. It occurs naturally due to the difference in density between the hot flue gases inside the chimney and the cold outside air. This pressure difference pulls air through the boiler and exhausts gases through the chimney. The chimney height is important. Taller chimneys create more draft. However, this method is less reliable and depends on outside weather, especially wind and temperature. Advantages of natural draft. Simple construction. No moving parts or external power required. Disadvantages. Can't be controlled easily. Not suitable for high-capacity boilers. Example: in small textile factories, natural draft is enough to run a simple boiler. Slide 4. Artificial draft. In contrast, artificial draft is created by using mechanical devices like fans. There are two main types. Forced draft. A fan forces air into the furnace. Induced draft. A fan pulls flue gases out of the furnace. These systems offer better control over combustion. You can adjust the fan speed to regulate the air supply and ensure proper burning of fuel. Advantages. Suitable for large boilers. Works under all weather conditions. Provides stable and controllable combustion. Disadvantages. Costly setup. requires electricity and regular maintenance. Example: thermal power plants always use artificial draft to manage combustion in large boilers. Slide 5. Comparison: natural vs artificial draft. Here's a side-by-side comparison to help you understand the difference better. 1. Generation method. Natural draft depends on the temperature difference between flue gases and the atmosphere. Artificial draft uses fans. 2. Control. Natural draft can't be adjusted easily. Artificial draft is fully controllable. 3. Cost. Natural is cheap in the long run. Artificial involves setup cost and operational cost, electricity and maintenance. 4. Efficiency. Artificial draft gives higher efficiency due to controlled combustion and better air-fuel ratio. 5. Capacity. Artificial draft supports high steam generation. Natural draft is suitable only for small boilers. 6. Flexibility. Artificial draft adapts better to changes in load. 7. Reliability. Artificial systems are more reliable in industrial operations as they work consistently in all environments. 8. Maintenance. Natural draft systems need chimney cleaning. Artificial draft systems require fan and motor maintenance. By understanding both systems, students can choose appropriate designs in real-world applications depending on the size and need of the boiler.